You've been lied to, not by your teachers, not by your parents, not by the scientists who spent their lives peering into the cosmos through billion-dollar telescopes. They weren't trying to deceive you, but the truth about our universe is so fundamentally alien, so impossibly vast and empty, that every attempt to explain it has been a beautiful, necessary fiction. Tonight, that fiction ends. Look around you right now. Feel the chair beneath you, the air against your skin, the solid ground under your feet. Everything you can touch, taste, see, and breathe represents less than 5% of everything that exists. Less than 5%. The rest? It's not just invisible, it's incomprehensible. You are not living in a universe filled with stars and planets and cosmic wonders. You are living in something far stranger, an endless void punctuated by the rarest of accidents. Tiny islands of matter floating in an ocean of absolutely nothing. But here's what will shatter your understanding of reality: that nothing isn't empty. It's not the absence of something. It's the presence of something we can't name, can't measure, can't understand. And it's not just filling the spaces between stars. It's here, right now, flowing through your body, through every atom in your brain, through the very thoughts you're having as you process these words. You are not separate from the cosmic void. You are swimming in it. The Big Bang, that moment of explosive creation we've all been taught to imagine, never banged at all. There was no sound, because sound needs matter to travel through. And before that moment, there was no matter. There wasn't even space for matter to exist in. But more disturbing than the silence of creation is this: the Big Bang might not have been a beginning. It might have been an interruption in something that had been going on forever, something that continues to go on around us, through us, in ways that would drive you insane if you could perceive them directly. Imagine standing in the middle of the Pacific Ocean at midnight, under a moonless sky with no land in sight in any direction. Now imagine that ocean is 1 trillion times larger, and instead of water, it's filled with something that doesn't interact with light, doesn't make sound, doesn't respond to touch. Now imagine that every molecule of water in that impossible ocean is replaced by a space larger than our entire solar system. You're getting close to grasping the emptiness we're suspended in. But you're not close enough, because that emptiness, it's expanding. Right now, as you sit there, the fabric of space itself is stretching, pulling apart, creating more nothingness between the tiny specks of matter that occasionally condense into stars and planets, and, occasionally, into beings like you who can look up and wonder why they exist at all. The universe isn't just mostly empty, it's becoming more empty with every passing second. The distances between galaxies are growing so fast that light itself, the fastest thing in the universe, can never catch up. There are entire galaxies moving away from us so quickly that we will never see them, no matter how long we wait, no matter how powerful our telescopes become. But here's the truly haunting part. If you could somehow step outside our universe and look back at it, you wouldn't see anything at all. No grand spiral of galaxies, no cosmic web of light and matter. You'd see a point so small, it would make the period at the end of this sentence look like a galaxy. All of this, every star, every planet, every thought you've ever had, every person you've ever loved, compressed into a space smaller than the head of a pin. And around that point, infinite darkness. Not the darkness of night, which is just the absence of local light sources. The darkness of absolute nothingness, stretching forever in directions that don't have names, You might be wondering how we know any of this. How can scientists claim to understand something so vast and empty that it defies every instinct we have about reality? The answer will disturb you. We know because we've been measuring the darkness. For decades, astronomers have been pointing their instruments not at the bright stars and colorful nebulae, but at the empty spaces between them. And those empty spaces have been talking back. They've been revealing secrets about the nature of existence that no human mind was ever meant to comprehend. When you look up at the night sky, you're not seeing the universe as it is. You're seeing a lie of perspective, a trick of scale that makes it seem like space is full of light and wonder. The truth is, if you could shrink yourself down to the size of an electron and travel through what we call solid matter, you would discover that atoms themselves are mostly empty space. The nucleus of an atom, containing almost all of its mass, occupies roughly 1/10 trillionth of the atom's total volume. If an atom were the size of a football stadium, its nucleus would be smaller than a marble sitting at the center of the field. Everything you think of as solid, your body, the walls around you, the earth beneath your feet, is almost entirely empty space, held together by forces we still don't fully understand. Now scale that up. If atoms are mostly empty space and atoms make up planets, and planets orbit through vast empty spaces around stars, and stars are separated by distances so large that light takes years to cross them, and galaxies are separated by distances so large that light takes billions of years to cross them, then what you're really living in is emptiness, nested inside, emptiness nested inside emptiness. Like a cosmic set of Russian dolls, where each doll is 99.99% hollow. But the story gets stranger, because that emptiness between galaxies isn't stable. It's not just sitting there, quietly maintaining the gaps between islands of matter. It's growing, accelerating, driven by something scientists have had to call dark energy, because we have no idea what it actually is. Imagine you're in a room, and the walls start moving away from you, slowly at first, then faster and faster. But it's not just the walls. The space between the walls is multiplying, creating more room, more distance, more emptiness. That's what's happening to our universe right now, and it's happening everywhere, at every scale, all the time. This acceleration means that the universe has a horizon, a boundary beyond which we can never see, no matter how long we wait or how advanced our technology becomes. Light from beyond that horizon will never reach us, because the space between us and those distant regions is expanding faster than light can travel through it. We are essentially trapped in an island of observable reality, surrounded by an infinite ocean of the unknowable. And that island is shrinking. In cosmic terms, we are not explorers embarking on a journey of discovery. We are castaways watching our visible universe disappear over the horizon, one galaxy at a time. The mathematics of this emptiness are merciless. If you could count every star in the observable universe, all 200 billion trillion of them, and multiply each star by the average number of planets orbiting them, and then multiply that by every grain of sand on every beach on Earth, you still wouldn't approach the number that represents the ratio of empty space to matter in the universe. The number is so large that it doesn't fit into human language. It's not a million, or a billion, or a trillion. It's a number that would take more words to write out than there are atoms in your body. Yet somehow, impossibly, you exist. In this vast cosmic emptiness, where the chances of matter organizing itself into anything complex should be essentially zero, you have emerged. not just as a random collection of atoms, but as a thinking, feeling, conscious being capable of contemplating the very emptiness that surrounds and permeates your existence. You are a temporary pattern in the void, a brief arrangement of matter and energy that has learned to ask questions about its own existence. You are, in the most literal sense, the universe becoming conscious of itself. But consciousness itself might be the strangest thing of all in this empty cosmos. Your thoughts, your memories, your sense of self. Where are they located in the vast emptiness of your brain? Neurons are separated by synaptic gaps, and the electrical signals that create your thoughts travel across those gaps through empty space. Your consciousness is not housed in matter. It emerges from the interactions between matter across empty space. You are not just living in the cosmic void. You are made of it. Your mind is a pattern of activity and emptiness, a temporary organization of the same fundamental nothingness that fills the universe. This raises a question that should keep you awake at night. If the universe is mostly empty, and you are made of the same kind of emptiness, then what are you, really? Are you a solid being moving through empty space? Or are you a temporary disturbance in the void, no more substantial than a wave on the ocean? When you touch something, you're not actually making contact. The electrons in your fingers are repelling the electrons in the object through electromagnetic forces that operate across empty space. You have never truly touched anything in your life. You are a ghost interacting with other ghosts in a universe that is fundamentally haunted. The light reaching your eyes right now left its source years ago, traveling through unimaginable emptiness to reach you. The photons hitting your retina at this moment have been journeying through the void for longer than you've been alive, carrying information about events that may no longer be happening. You are not seeing the present. You are seeing the past, filtered through billions of miles of nothingness. Even the light from the sun, which seems immediate and constant, left the solar surface 8 minutes ago. You are always living in the shadow of the past, illuminated by light that has survived a journey through the cosmic void. And that void is not passive. It's not just empty space waiting to be filled. It's dynamic, energetic, possibly alive in ways we can't comprehend. Quantum mechanics tells us that even perfect vacuum, space with no matter, no energy, no anything, is actually bubbling with virtual particles that pop into existence and annihilate each other in timescales so brief that they exist in the gaps between moments. The emptiness itself is full of potential, pregnant with possibilities that exist for infinitesimally short periods before vanishing back into nothingness. You are surrounded by and made of a void that is constantly creating and destroying itself at scales smaller than perception. The implications are staggering. If empty space is not empty, if it's filled with constant creation and annihilation, with fields and forces and phenomena we're only beginning to detect, then the universe is not the cold, dead, mechanical place we once imagined. It's alive with invisible activity, humming with energies and processes that operate on timescales and spatial scales far beyond human perception. You are not alone in the darkness. You are swimming in an ocean of activity so subtle and swift that it might as well be magic. But perhaps the most disturbing revelation about cosmic emptiness is this. It might not be permanent. The forces that created the Big Bang, that inflated space itself in the first fraction of a second, that continue to drive the accelerating expansion of the universe, these forces might be unstable. There are theoretical scenarios in which the fabric of space itself could undergo a phase transition, like water suddenly freezing or boiling, changing the fundamental laws of physics in an instant. If this happened, it would propagate outward at the speed of light, erasing everything in its path, replacing our universe with something completely alien. The cosmic void that seems so eternal might be temporary, a brief arrangement of space and time that could collapse or transform without warning. You are reading these words in a universe that is not just mostly empty, it's precariously empty, balanced on the edge of phase transitions and quantum fluctuations that could rewrite the laws of reality at any moment. The emptiness around you is not stable. It's not guaranteed. It exists in a configuration that allows matter, allows energy, allows consciousness, allows you, but there's no cosmic law that says it must continue to exist this way. The void that gave birth to everything you know could swallow it just as easily. This is the true nature of your existence. You are a pattern of consciousness arising in an ocean of dynamic emptiness, sustained by forces you don't understand, surrounded by distances you can't comprehend, living in a universe that is expanding away from itself so quickly that most of it will forever remain unknowable. You are not just rare, you are impossible. The mathematical odds against your existence are so astronomical that your presence here reading these words is either the most extraordinary coincidence in the history of reality or evidence of something far stranger than coincidence operating in the cosmic void. The universe is not just mostly empty, it's impossibly empty, mysteriously empty, dangerously empty. And somehow, in the middle of all that emptiness, you happened. You are the universe's most unlikely achievement, its most temporary experiment, its most beautiful accident. You are what happens when nothingness dreams of something, when the void imagines itself into existence, when emptiness learns to think. But why? Why does the cosmic void occasionally condense into stars and planets and conscious beings who can contemplate their own existence? Why does a universe that is 99.999% empty bother to create the 0.001% that is you? The answer to that question, if there is one, lies hidden in the very emptiness that surrounds you, encoded in the dark energy that drives galaxies apart, whispered in the quantum fluctuations of space itself. To find it, you'll need to journey deeper into the void than any human has gone before, to places where space and time themselves begin to break down, where the familiar laws of physics dissolve into something far more mysterious and beautiful and terrifying than anything you've ever imagined. The cosmic void is not your enemy. It's not trying to erase you or render your existence meaningless. It's the canvas on which you are painted, the silence against which your voice has meaning, the darkness that makes your light visible. You are not separate from the emptiness. You are its most eloquent expression, its most conscious moment, its only known opportunity to understand itself. In a universe that is mostly nothing, you are something extraordinary. You are the void awakening to its own existence, learning to ask questions about the nature of nothingness itself. And those questions are about to take you on a journey through emptiness so vast and strange that by the time you return, if you return, you will never see reality. The same way again. The story begins with a deception so fundamental that even Einstein fell for it. For centuries, we believed the universe was static, a grand, unchanging stage where stars and planets performed their eternal dance. The cosmos was a clockwork mechanism, predictable and stable, with every celestial body locked in its proper place by the invisible hand of gravity. This wasn't just scientific theory, it was cosmic comfort. The universe had always been, and would always be, exactly as we found it. Then, in 1929, a man named Edwin Hubble pointed his telescope toward the darkness and discovered that everything we thought we knew was catastrophically wrong. Hubble wasn't looking for a revolution. He was simply measuring the light from distant galaxies, cataloging their colors and brightness like a cosmic accountant. But the numbers that came back from his observations were impossible. Every galaxy he could see, every single one, was moving away from us, not just drifting slowly, but racing away at speeds that defied comprehension. The more distant the galaxy, the faster it was fleeing, as if the universe itself was recoiling from our presence. But here's what made Hubble's discovery truly terrifying. The galaxies weren't moving through space. Space itself was carrying them away. The fabric of reality was stretching, expanding, creating new emptiness between every point in the cosmos with every passing second. Imagine standing on a balloon while someone inflates it. Except you can't feel the balloon, you can't see the balloon, and the balloon extends infinitely in all directions. You're not moving, but everything around you is racing away as the invisible surface beneath your feet expands into the void. This was the birth of modern cosmology, and with it came a revelation that should have shattered our understanding of existence. If the universe is expanding now, then it must have been smaller in the past. Much smaller. Wind the cosmic clock backward far enough, and you arrive at a moment when all of space, all matter, all energy, all time was compressed into a point smaller than the period at the end of this sentence. Not a point in space, a point that was space, containing the entirety of everything that would ever exist. We call this the Big Bang, but that name is a lie. There was no bang. There was no explosion. There was no moment when matter erupted into pre-existing space. Instead, there was something far stranger. The spontaneous appearance of space itself, inflating faster than light, creating distance where no distance had existed, birthing time where no time had flowed. In the first fraction of a second, a period so brief that human language has no words for it, the universe expanded from submicroscopic to larger than a grapefruit. Then it kept going, but even this mind-bending origin story contains a deeper mystery that most people never hear about. The Big Bang Theory explains how the universe expanded, but it cannot explain why it expanded into the particular configuration we see today. According to the mathematics of cosmic inflation, the early universe should have been perfectly smooth. A hot, dense soup of energy with no structure, no variation, no reason for matter to clump together into stars and galaxies and you. Yet somehow, impossibly, the universe was born with imperfections. Tiny quantum fluctuations, random variations in energy that existed for the briefest instant, were stretched by cosmic inflation into the seeds of everything we see today. These fluctuations were so small they existed at the boundary between something and nothing. Yet they became the gravitational anchors around which matter would eventually condense into the first stars, the first galaxies, the first planets capable of harboring life. Think about the absurdity of this for a moment. Your existence, everything you've ever seen or touched or loved, began as a quantum hiccup in the fabric of space-time, a random fluctuation that lasted for a duration shorter than thought itself. You are here because nothingness sneezed, and that sneeze became the foundation of reality as we know it. But the strangeness of cosmic origins goes deeper still. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. In the first moments after the Big Bang, temperatures reached 100 billion degrees, so intense that matter couldn't exist in any form we would recognize. There were no atoms, no molecules, no particles that would survive longer than it takes light to cross the nucleus of an atom. The universe was pure energy, seething and roiling in configurations that would annihilate any complex structure instantly. For the first 380,000 years, longer than all of recorded human history, the universe was opaque. Light couldn't travel more than a few inches before being absorbed and re-emitted by the dense plasma that filled all of space. If you could somehow travel back to this era and open your eyes, you would see nothing. Not darkness. That would imply the absence of light. You would see a wall of radiation so intense and uniform that it would be like trying to see through the surface of the sun, except that surface would extend infinitely in every direction. Then, in a cosmic instant, everything changed. The universe cooled just enough for the first atoms to form. Hydrogen and helium, the simplest possible arrangements of matter. Suddenly, light could travel freely through space for the first time. The cosmic fog lifted, and the universe became transparent. This light, the first light, is still traveling through space today, stretched by 13.8 billion years of cosmic expansion into faint microwaves that fill every cubic inch of the universe around you. You are bathed in the afterglow of creation itself, the fossil radiation of the moment when the cosmos opened its eyes and learned to see. But here's what should haunt your dreams. That first light reveals something deeply disturbing about the nature of our universe. When we map the patterns in this cosmic microwave background radiation, we see the universe as it was when it was only 380,000 years old, a baby by cosmic standards. And that baby universe was almost perfectly smooth. The variations in temperature and density that would eventually become galaxies and stars were incredibly tiny, differences of only a few parts in 100,000. This creates a paradox that cosmologists call the horizon problem. Different regions of the early universe were separated by distances so vast that light couldn't have traveled between them since the Big Bang began. They had no way to communicate, no way to coordinate their temperatures or properties. Yet when we observe the cosmic microwave background, we find that these disconnected regions have almost exactly the same temperature, say, temperature that agrees to within a fraction of a degree across the entire observable universe. It's as if you walked into a vast library where no one had ever spoken to anyone else, yet every person was reading the exact same page of the exact same book at the exact same moment. The coordination is so perfect it seems impossible. Unless something connected these regions before the observable universe began. Unless our cosmic origins are stranger and more mysterious than even the Big Bang theory suggests. This is where cosmology ventures into territory that feels more like science fiction than science fact. To solve the horizon problem, physicists have proposed that the early universe underwent a period of cosmic inflation, a brief epoch when space expanded faster than light, stretching quantum fluctuations to cosmic scales and smoothing out irregularities that would otherwise have made star formation impossible. During inflation, a region smaller than a proton expanded to larger than a basketball in less time than it takes light to cross an atomic nucleus. But inflation creates as many mysteries as it solves. If the universe can expand faster than light, and it can, because space itself is expanding, not matter moving through space, then what limits this expansion? Where does it end? Current theories suggest that inflation might never end. While our local region of space-time has settled into the slow, steady expansion we observe today, vast regions of the cosmos might still be inflating exponentially, creating new universes, new realities, new physics that we can never observe or understand. This brings us to one of the most unsettling implications of modern cosmology. Our entire observable universe, everything we can see, detect, or ever hope to reach, might be just one bubble in an infinite ocean of cosmic inflation. There might be countless other universes beyond our cosmic horizon, each with different laws of physics, different constants of nature, different possibilities for the emergence of matter, energy, and consciousness. Most of these universes would be sterile, unable to form stars or planets or life of any kind. We might exist in an impossibly rare pocket of cosmic inflation, where the laws of physics happen to arrange themselves in just the right way to allow complexity to emerge. But even in our supposedly life-friendly universe, the emergence of complexity seems miraculous to the point of impossibility. After the cosmic microwave background decoupled from matter, the universe entered what cosmologists call the Dark Ages, a period lasting hundreds of millions of years when no stars shone, no galaxies glowed, no light illuminated the cosmic void. The universe was filled with hydrogen and helium gas, slowly cooling and expanding into darkness, with only the faint afterglow of the Big Bang to mark the passage of time. During these dark ages, gravity was working in secret, amplifying those tiny quantum fluctuations from the early universe into the first gravitational wells, invisible scaffolds of space-time curvature, where matter would eventually begin to collect. These were not places in any ordinary sense, but distortions in the fabric of space itself, regions where time moved slightly slower, and matter felt a subtle pull toward collapse. Imagine the early universe as a vast, dark ocean with invisible currents flowing beneath the surface. For hundreds of millions of years, nothing was visible above the waves, but beneath. Tremendous forces were building toward something unprecedented in cosmic history: the birth of the first stars. But here's what makes stellar birth so impossible and beautiful. Stars shouldn't exist. The nuclear fusion that powers every star in the sky requires temperatures and pressures so extreme that they should destroy any attempt at star formation before it begins. For hydrogen atoms to fuse into helium, they must be compressed to densities greater than the center of the Earth and heated to temperatures exceeding 10 million degrees. The electromagnetic force, the same force that prevents your hand from passing through a solid wall, fights against this compression with tremendous violence. Yet somehow, gravity wins. Not through brute force, but through patience. Over millions of years, gravity gathers hydrogen gas into clouds, then compresses those clouds until they begin to heat up. The hotter they get, the more violently the gas tries to expand. But gravity holds firm, squeezing tighter and tighter until something magical happens. The temperature and pressure at the center of the cloud reach the threshold where hydrogen nuclei overcome their electromagnetic repulsion and fuse together, releasing energy in a burst of nuclear fire. At that moment, a star is born. Not just a ball of hot gas, but a nuclear furnace that will burn for millions or billions of years, converting matter into energy according to Einstein's most famous equation. The energy released by this fusion creates an outward pressure that exactly balances the inward pull of gravity, creating a stable star that can shine across cosmic distances and warm the surfaces of planets that might, under incredibly rare circumstances, develop the chemistry necessary for life. But stellar birth reveals another cosmic paradox. The universe simultaneously creates and destroys the very conditions necessary for its own complexity. Every star that forms removes hydrogen gas from the cosmic inventory, converting it into heavier elements through nuclear fusion. When massive stars die in supernova explosions, they scatter these heavier elements, carbon, oxygen, silicon, iron, into space, where they can eventually be incorporated into new stars, new planets, and new possibilities for chemistry and biology. This process of stellar evolution is simultaneously the universe's greatest creative force and its most efficient destroyer. Each generation of stars uses up more of the cosmic fuel, creating more complex elements but also more stellar remnants. White dwarfs, neutron stars, black holes that can never again participate in the cycle of stellar birth and death. The universe is running down, using up its ability to make new stars, new worlds, new opportunities for consciousness to emerge. Current estimates suggest that star formation peaked billions of years ago and has been declining ever since. We live in a universe that has already passed its prime, already begun its long slide toward darkness. In the far future, when the last stars have burned out and the universe has expanded and cooled beyond the possibility of new star formation, the cosmos will enter an era of darkness that will last infinitely longer than the brief, bright epoch of stellar activity we're witnessing now. Yet even this grim cosmic timeline contains mysteries that challenge our understanding of reality itself. The expansion of the universe, which began with the Big Bang and drove cosmic inflation, should be slowing down. The gravitational attraction between galaxies should be gradually winning the battle against expansion, eventually causing the universe to contract in a big crunch that would mirror the Big Bang in reverse. But in 1998, observations of distant supernovae revealed something that should be impossible. The expansion of the universe is accelerating. Not only is space still growing, creating new emptiness between galaxies, but the rate of growth is increasing. Something is pushing against gravity, driving cosmic expansion faster and faster, ensuring that the universe will expand forever into a state of perfect cold, empty darkness. This mysterious force has been named dark energy. But the name reveals our ignorance more than our understanding. Dark energy comprises roughly 70% of everything that exists in the universe, yet we have no idea what it is, where it comes from, or why it exists. It could be a property of space itself, a kind of cosmic anti-gravity that becomes stronger as space expands. It could be the result of quantum fields that we haven't discovered yet. It could be evidence that our understanding of gravity itself is fundamentally flawed. Or it could be something even stranger, a sign that our universe is not isolated, that it exists in contact with other realities, other dimensions, other universes that exert forces we can detect but cannot understand. Dark energy might be the shadow cast by hyperdimensional physics, operating on scales and in directions that human minds cannot visualize. But dark energy is not the only invisible inhabitant of our cosmos. Observations of galactic rotation curves and gravitational lensing have revealed that ordinary matter, the stuff that makes up stars, planets, and you, comprises only about 5% of the total mass energy in the universe. Another 25% consists of something called dark matter, which interacts gravitationally with ordinary matter but remains completely invisible to all forms of electromagnetic radiation. Dark matter is everywhere around you. passing through your body at this very moment without leaving any trace of its presence. It might be composed of exotic particles that were created in the first moments after the Big Bang, but have since cooled and dispersed throughout space. It might be primordial black holes formed from quantum fluctuations in the early universe. It might be evidence of extra dimensions that we can detect only through their gravitational effects. The truly unsettling reality is that you live in a universe where 95% of everything that exists is completely invisible to you. You can see stars and galaxies and cosmic structures, but these visible phenomena are merely the foam on top of an ocean of dark matter and dark energy that determines the fate of everything you can observe. It's as if reality has two levels: the bright, complex, beautiful universe of matter and energy that supports life and consciousness, and the vast, dark, unknowable universe of invisible forces that actually controls cosmic evolution. This raises a question that should fundamentally alter your perspective on existence. If the universe has no edge, then where does it begin? If space itself is expanding, what is it expanding into? If the Big Bang created space and time, what existed before the Big Bang to contain that moment of creation? These questions have no answers within our current understanding of physics, yet they point toward something profound about the nature of reality. The universe might not be a place at all, but a process, an ongoing creation of space, time, matter, and possibility that operates according to rules we're only beginning to glimpse. You might not be living in the universe so much as participating in its continuous creation, helping to determine through your observations and choices which of infinite potential realities becomes actual. The emptiness that surrounds you is not passive space waiting to be filled. It's an active participant in cosmic evolution, a dynamic medium that carries forces and fields and possibilities that shape the development of everything from quantum particles to galactic clusters. The void is alive, and it's been waiting 13.8 billion years for something like consciousness to emerge. Something capable of observing the universe and, through that observation, participating in its ongoing creation. What you're about to discover is that this participation goes deeper than you ever imagined. The mathematics that govern our universe contain a secret so disturbing that most physicists spend their entire careers trying to avoid confronting it directly. Hidden within Einstein's elegant equations of general relativity, lurking in the quantum mechanical descriptions of subatomic reality, embedded in the very structure of space-time itself, are solutions that should not exist. Mathematical monsters that describe regions, where the familiar laws of physics break down completely and reality becomes something unrecognizable. These are called singularities, and they are everywhere. You've been taught to think of black holes as exotic objects, rare cosmic curiosities that exist only in the most extreme environments of the universe. But the truth is far more unsettling. Every black hole contains at its center a point of infinite density and zero volume, where the curvature of space-time becomes so extreme that space and time themselves cease to have meaning. And according to our best theories, the Big Bang itself emerged from just such a singularity, not a place in space, but a condition where space, time, matter, and energy were compressed into a mathematical point that defies every intuition you have about the nature of reality. Imagine trying to divide by zero. Your calculator gives you an error message because the operation is undefined. It breaks the rules of mathematics itself. Singularities are like cosmic division by zero errors, places where the equations that describe reality produce infinite answers, infinite curvatures, infinite densities. They are points where the universe's operating system crashes, where the software of physical law encounters a problem it cannot solve. But here's what should keep cosmologists awake at night. These mathematical impossibilities are not just theoretical curiosities. They appear to be fundamental features of the universe we actually live in. Every time matter collapses beyond a certain critical density, the Schwarzschild radius, it creates a region of space-time so warped that nothing, not even light, can escape. The matter continues collapsing until it reaches infinite density at a point of zero size. Not very small, zero. Not very dense, infinitely dense. The mathematics is unambiguous, and the mathematics says that such objects must exist. Yet infinity has no place in physics. Every measurement we can make, every observation we can perform, every quantity we can detect is finite. The appearance of infinities in our equations is usually a sign that our theories are incomplete, that we're missing some crucial piece of the puzzle. But with singularities, we've reached the limits of human knowledge. Our most successful theories, general relativity and quantum mechanics, make precise, testable predictions about almost everything in the universe. Yet they cannot tell us what happens at the center of a black hole or in the first instant of the Big Bang. This breakdown of physical law is not a failure of science. It's a window into something deeper and stranger than science can currently encompass. When Einstein's equations predict infinite curvature, they're not wrong. They're pointing toward regions of reality where the concepts of space and time themselves become meaningless, where the universe exhibits behavior so alien that human language has no words to describe it. Consider the journey to the center of a black hole, as described by general relativity. As you approach the event horizon, the boundary beyond which escape becomes impossible, time begins to slow down relative to the outside universe. An observer watching your descent would see you moving more and more slowly, your image red-shifting and fading until it freezes at the horizon, never quite crossing the boundary. But from your perspective, you pass through the horizon normally, experiencing nothing unusual as you cross this point of no return. Once inside, however, the geometry of space-time becomes so distorted that the concepts of inward and outward lose their meaning. The singularity at the center is no longer a place you're moving toward. It's a moment in time you're moving toward, as inevitable as tomorrow. No force in the universe can prevent you from reaching it, because reaching the singularity is not a matter of spatial motion, but temporal progression. You are falling not through space, but through time itself, toward a moment when the very structure of space-time ends. But quantum mechanics suggests something even stranger might be happening. According to quantum field theory, the intense gravitational fields near a black hole should cause space itself to bubble with virtual particle pairs, electrons and positrons, photons and antiphotons, constantly appearing and annihilating in the vacuum of empty space. Near the event horizon, some of these particles fall into the black hole while others escape, carrying away energy and causing the black hole to slowly evaporate through a process called Hawking radiation. This quantum evaporation creates a paradox that has puzzled physicists for decades. If black holes evaporate completely, what happens to the information that fell into them? Quantum mechanics insists that information cannot be destroyed. Every particle, every quantum state, every bit of data about the universe must be preserved in some form. But if a black hole evaporates completely, leaving only random thermal radiation, where does the information go? Some physicists argue that the information is preserved in subtle correlations in the Hawking radiation, encoded in ways so complex that we cannot currently detect or decode them. Others suggest that black holes never evaporate completely, leaving behind remnants that somehow contain all the information that ever fell in. Still others propose that the information is destroyed, requiring us to abandon one of the most fundamental principles of quantum mechanics, but perhaps the most radical solution to the information paradox suggests that black holes don't actually have interiors at all. According to this theory, what we interpret as matter falling into a black hole is actually matter being scrambled and encoded on the black hole's surface, its event horizon. The three-dimensional reality we perceive might be a holographic projection of information stored on a two-dimensional boundary, like a cosmic version of the holograms on credit cards. This holographic principle implies something profound about the nature of reality itself. If all the information about the interior of a black hole can be encoded on its two-dimensional surface, then perhaps all the information about our three-dimensional universe can be encoded on its two-dimensional boundary. You might think you're living in a three-dimensional world, but you could actually be a pattern of information holographically projected from the edge of space-time itself. The implications extend far beyond black holes. If the holographic principle is correct, then the universe might have fundamentally fewer dimensions than we perceive. The depth, the volume, the three-dimensional space you move through might be emergent properties of information processing on a distant boundary. You might be less like a person moving through space and more like a character in a cosmic video game, with your apparent three-dimensional existence generated by computations occurring on a screen you can never see or touch. But holography is just one of many radical solutions to the mysteries of cosmic architecture. Another approach suggests that singularities might not exist at all, that quantum effects become important before matter can collapse to infinite density, creating exotic objects called gravastars or fuzzball solutions that avoid the mathematical infinities that plague classical black holes. According to these theories, what we interpret as black holes might actually be incredibly dense, quantum mechanical objects with surfaces that hover just outside their would-be event horizons. They would appear almost identical to classical black holes to distant observers, but they would have no interior, no singularity, no region where physics breaks down. They would be strange but finite objects, obeying quantum mechanical rules even under the most extreme gravitational conditions. Yet these alternatives to classical black holes create their own mysteries. If gravastars or fuzzballs are the correct description of collapsed matter, then the universe contains objects so exotic that they exist in quantum superposition states that encompass multiple possible configurations simultaneously. A fuzzball black hole might exist in a quantum superposition of all possible arrangements of its constituent strings or particles, with its apparent classical properties emerging only when observed by macroscopic detectors. This brings us to one of the deepest puzzles in modern physics: the measurement problem in quantum mechanics. According to the standard interpretation of quantum theory, particles exist in superposition states, simultaneously occupying multiple positions, having multiple velocities, existing in multiple configurations until they are observed or measured. At the moment of measurement, the superposition collapses, and the particle assumes a single, definite state. But what constitutes a measurement? When does the collapse occur? These questions become cosmologically significant when we consider the early universe, which existed for billions of years before any conscious observers evolved to measure it. If quantum superposition requires conscious observation to collapse, then what determined the actual configuration of the early universe? Were galaxies, stars, and planets existing in quantum superposition until the first intelligent beings evolved to observe them? Some interpretations of quantum mechanics suggest that conscious observation is indeed necessary to collapse quantum superpositions, implying that consciousness plays a fundamental role in determining the structure of reality. According to this view, the universe might exist in a superposition of all possible configurations until conscious beings evolve to observe it, at which point it retroactively assumes the configuration that made their evolution possible. This participatory universe interpretation suggests that consciousness and cosmos are not separate phenomena but aspects of a single, self-organizing system. The universe creates consciousness, and consciousness, through its observations, participates in creating the universe. You are not just observing reality. You are helping to determine which of many possible realities becomes actual through your choices about what to observe and how to observe it. But other interpretations of quantum mechanics suggest something even stranger, that all possible quantum outcomes occur simultaneously in parallel universes that branch off from each other at every moment of quantum measurement. According to the many worlds interpretation, when a quantum system is measured, the universe splits into multiple parallel realities, each containing a different outcome of the measurement. From this perspective, every quantum event, every radioactive decay, every photon detection, every molecular interaction causes the universe to branch into multiple parallel copies. These parallel universes are all equally real, all equally valid, but they are isolated from each other by the quantum mechanical process that creates them. You exist in one branch of this vast quantum multiverse, but countless other versions of you exist in parallel, branches where different quantum outcomes occurred. The many worlds interpretation implies that reality is not a single timeline, but an ever-branching tree of possibilities, with new universes being created every instant as quantum events unfold. Most of these parallel universes would be nearly identical to ours, differing only in microscopic quantum details, but some would be radically different. Universes where different choices were made, different quantum outcomes occurred, different evolutionary paths were followed. In some of these parallel universes, you never existed. In others, you made different choices, lived different lives, became different people. In still others, the laws of physics themselves might be different, allowing for forms of matter, energy, and consciousness that are impossible in our reality. The multiverse might contain every possible variation of reality, every conceivable arrangement of matter and energy, every potential path that quantum mechanics allows. But the multiverse hypothesis raises profound questions about the nature of probability and existence. If all possible outcomes occur in parallel universes, what determines which universe you find yourself in? Why do you experience this particular reality rather than one of the countless alternatives? Is there something special about your current universe? Or are you simply one of countless observers, each convinced that their particular reality is the real one? Some physicists argue that the multiverse provides a natural explanation for the fine-tuning of physical constants in our universe. The strengths of fundamental forces, the masses of elementary particles, the rate of cosmic expansion. All of these parameters seem to be precisely adjusted to allow for the formation of stars, planets, and complex chemistry. If any of these constants were even slightly different, the universe would be sterile, unable to support the emergence of life and consciousness. Rather than requiring a cosmic designer to fine-tune these parameters, The multiverse hypothesis suggests that all possible values of physical constants are realized in different parallel universes. We find ourselves in a universe with life-supporting parameters, not because these parameters were specially chosen, but because we could only evolve in a universe where such parameters happen to exist. Universes with different physical constants exist in parallel, but they contain no observers to wonder about their properties. This anthropic reasoning extends beyond the multiverse to the structure of space-time itself. Recent developments in string theory and quantum gravity suggest that space and time might not be fundamental features of reality, but emergent properties that arise from more basic, non-spatial, non-temporal processes. According to these theories, the universe at its deepest level might be neither spatial nor temporal, but informational, a vast computation or pattern of relationships that generates the appearance of space, time, matter, and energy. Imagine reality as a cosmic film reel, where time is not flowing but every moment, past, present, and future, already exists as static frames. Your perception of temporal flow would be an illusion created by your consciousness moving through these pre-existing moments, like a spotlight illuminating successive frames of an eternal movie. This block universe interpretation of relativity suggests that all of history, from the Big Bang to the end of time, exists simultaneously in a four-dimensional structure called space-time. But if time is an illusion, what about causation? What about free will? If the future already exists, are your choices predetermined? These questions probe the relationship between consciousness and cosmos, between the subjective experience of temporal flow and the objective structure of space-time, described by physics. Some interpretations suggest that consciousness itself might be the source of temporal directionality, that the arrow of time emerges from the process of conscious observation and memory formation. According to this view, the universe without conscious observers would be timeless, existing as a static block of space-time with no preferred direction. Consciousness creates time by observing events and forming memories that distinguish past from future. But string theory suggests an even more radical possibility, that space and time are emergent properties of quantum entanglement between more fundamental entities. According to the holographic principle applied to string theory, the geometry of space-time might arise from the pattern of quantum correlations between bits of information on the boundary of the universe. Space would not be a stage where physics unfolds, but a derived quantity that emerges from more basic quantum mechanical processes. This emergent space-time hypothesis implies that the three spatial dimensions and one temporal dimension, experience, are not fundamental features of reality, but collective behaviors that arise from underlying quantum mechanical phenomena, much like temperature and pressure emerge from the statistical behavior of countless molecules. At the deepest level, reality might be neither spatial nor temporal, but purely informational. Patterns of correlation and entanglement that generate the appearance of a classical universe. If space-time is emergent, then the cosmic architecture you perceive, galaxies separated by vast distances, stars evolving over billions of years, the expansion of the universe itself, might be secondary phenomena arising from more primitive processes that operate according to rules we don't yet understand. The emptiness of space, the flow of time, the separation between objects might all be artifacts of your macroscopic perspective on a reality that is fundamentally non-spatial and non-temporal. The deeper you probe into the cosmic architecture of emptiness, the more reality begins to resemble a detective story, where every clue leads to a more baffling mystery. The universe seems to be constructed from paradoxes, self-contradicting phenomena that should be impossible, yet appear to be fundamental features of existence itself. These are not merely academic puzzles for physicists to solve, but cracks in the foundation of reality that suggest our entire understanding of existence might be profoundly incomplete. Consider the paradox that should haunt every moment of your existence: the arrow of time. You experience time as flowing from past to future in a steady, irreversible stream. You remember yesterday but not tomorrow. You can influence the future but not the past. You age, entropy increases, and the universe evolves from ordered to disordered states. Yet the fundamental laws of physics are almost entirely time-symmetric. They work equally well whether time flows forward or backward. Newton's laws of motion, Einstein's equations of general relativity, the Schrödinger equation of quantum mechanics, all of these can be run in reverse with equal validity. If you could record a movie of planets orbiting the sun and play it backward, the backward motion would obey the same gravitational laws as the forward motion. If you could watch a movie of two particles colliding and exchanging energy, the reverse collision would follow the same quantum mechanical principles. So why does time seem to have a preferred direction? Why does the universe exhibit a clear arrow pointing from past to future, when the laws governing that universe are indifferent to temporal direction? This is not just a philosophical puzzle. It strikes at the heart of what it means to exist as a conscious being in a physical universe. The conventional answer involves entropy, the measure of disorder in a system. The second law of thermodynamics states that entropy always increases in isolated systems, providing a thermodynamic arrow of time that points from low entropy states toward high entropy states. Your ability to remember the past, but not the future, arises because memory formation requires low entropy information processing that increases the overall entropy of the universe. But this explanation only pushes the mystery deeper. Why did the universe begin in a low entropy state? The Big Bang represents one of the most incredibly ordered configurations possible. All matter and energy compressed into a tiny region of space-time with minimal entropy. From this initial state of extraordinary order, the universe has been evolving toward increasing disorder for 13.8 billion years, creating the thermodynamic gradient that makes life, consciousness, and temporal directionality possible. Yet there is no fundamental reason why the universe should have begun in such an improbably ordered state. According to statistical mechanics, the overwhelming majority of possible initial conditions would have produced a universe that was already maximally disordered. A uniform soup of particles at equilibrium with no structure, no gradients, no possibility for complexity to emerge. The fact that our universe began in one of the extraordinarily rare low-entropy configurations that allow for evolution and consciousness is perhaps the most improbable thing that has ever happened. Some cosmologists argue that this initial low entropy might be explained by cosmic inflation, the hypothetical period of exponential expansion that occurred in the first fraction of a second. After the Big Bang, inflation could have smoothed out irregularities and created a nearly uniform universe that appeared to have low entropy relative to its enormous size. But inflation itself requires fine-tuned initial conditions, merely pushing the entropy problem back one step further. Others suggest that the arrow of time might be an illusion, that the universe as a whole is time-symmetric. But conscious observers like yourself can only emerge in regions where entropy happens to be increasing. According to this view, there might be other regions of space-time where entropy decreases, where effects precede causes, where the future influences the past. But conscious beings in those regions would perceive their local entropy gradient as the forward direction of time, creating multiple, adinankidur chantit salansraivand, conflicting arrows of time within the same universe. This possibility opens up one of the most disturbing questions in cosmology. Is the future fixed? If the laws of physics are deterministic, then the current state of the universe completely determines all future states. Every choice you will ever make, every thought you will ever think, every quantum event that will ever occur, all of it would be inevitable consequences of the universe's present configuration. Free will would be an illusion. Consciousness would be a passive observer of predetermined events, and the future would be as fixed and unchangeable as the past. But quantum mechanics complicates this deterministic picture by introducing fundamental randomness into physical processes. When a radioactive atom decays, when a photon passes through a polarizing filter, when any quantum measurement occurs, the outcome appears to be genuinely random, not just unpredictable due to our ignorance, but truly undetermined until the moment of measurement. This quantum indeterminacy might provide the space necessary for free will and consciousness to have genuine causal efficacy. Yet even quantum randomness creates its own paradoxes. If your choices are determined by random quantum events in your brain, are they really your choices? Random is not the same as free. A coin flip is random, but it's not an expression of the coin's free will. For consciousness to have genuine agency, it must somehow transcend both deterministic causation and random chance, operating according to principles that are neither mechanistic nor arbitrary. Some interpretations of quantum mechanics suggest that consciousness might indeed transcend ordinary causation by participating in the process of quantum measurement itself. According to these theories, conscious observation doesn't just detect pre-existing quantum states. It participates in creating them by collapsing quantum superpositions into definite outcomes. Consciousness would not be subject to physical laws, but would help determine which physical laws become manifest through the choices observers make about what to observe and how to observe it. But this participatory role of consciousness creates another paradox. The observer effect in quantum mechanics seems to require conscious beings to play a fundamental role in determining the structure of reality. Yet conscious beings are themselves products of physical processes governed by quantum mechanics. Consciousness helps create the universe, but the universe creates consciousness. This circular causation challenges the linear, mechanistic worldview that science has traditionally assumed. The paradox deepens when you consider the cosmic implications of quantum mechanics. If conscious observation is necessary to collapse quantum superpositions, then what determined the structure of the universe during the billions of years before conscious observers evolved? Was the early universe existing in a vast quantum superposition of all possible configurations until the first living beings appeared to observe it? Did galaxies, stars, and planets exist in quantum limbo until consciousness evolved to bring them into definite existence? One proposed solution involves what physicists call decoherence, the process by which quantum systems become entangled with their environments in ways that effectively collapse superpositions without requiring conscious observation. According to this view, the universe has been collapsing its own quantum superpositions through environmental interaction since the beginning of time, with consciousness playing no special role in determining reality. But decoherence doesn't solve the deeper paradox. It merely relocates it. If the environment can collapse quantum superpositions, then what determines the configuration of the environment? The problem of quantum measurement is like an infinite regress of mirrors, with each potential solution simply reflecting the mystery back onto a deeper level of reality. Perhaps more disturbing than the measurement problem is the cosmic coincidence problem, the observation that dark energy and dark matter happen to have comparable densities in the current epoch of cosmic history. Dark energy, which drives the accelerating expansion of space, currently comprises about 70% of the universe's total mass energy. Dark matter, which provides the gravitational scaffolding for galaxy formation, comprises about 25%. Ordinary matter, the stuff that makes up stars, planets, and you, comprises only about 5%. These percentages are not constants. They change as the universe evolves. In the early universe, radiation dominated over matter, which dominated over dark energy. In the far future, dark energy will dominate so completely that galaxies will be carried away from each other faster than light can travel between them. Yet we happen to live in the brief cosmic epoch when dark energy and dark matter have comparable densities, when the universe is old enough for complex chemistry to develop, but young enough for stars to still be forming. This timing seems suspiciously convenient. Of all the possible moments in cosmic history when conscious beings might evolve, why do we find ourselves living precisely when the cosmic energy budget is divided between dark matter and dark energy in roughly comparable proportions? The coincidence is so striking that it suggests either incredible luck or some deeper principle that connects the emergence of consciousness to the dynamics of cosmic expansion. Some cosmologists argue that this apparent coincidence is explained by anthropic reasoning. Conscious beings can only evolve during epochs when the cosmic expansion rate allows for galaxy formation and stellar nucleosynthesis. We observe comparable densities of dark matter and dark energy because we could only exist during the brief period when such comparability occurs. Universes dominated by dark energy would expand too rapidly for structure formation, while universes dominated by dark matter would collapse too quickly for complex chemistry to develop. But anthropic reasoning creates its own philosophical difficulties. If we can explain cosmic coincidences by noting that we could only exist in universes where such coincidences occur, then almost any observation becomes anthropically inevitable. The anthropic principle risks becoming an untestable, unfalsifiable explanation that can account for any observation after the fact, but makes no specific predictions about what we should observe. More troubling is the implication that our existence might require an enormous multiverse of failed universes, realities where dark energy dominated too early, where dark matter clumped too efficiently, where the physical constants were tuned differently, and consciousness never emerged. For every successful universe that produces observers, there might be countless sterile universes where complexity never develops beyond the simplest possible forms. This raises profound questions about the nature of existence itself. If consciousness requires such precise fine-tuning of cosmic parameters that it can only emerge in an infinitesimally small fraction of possible universes, then what does it mean to say that consciousness exists at all? Are conscious beings like yourself incredibly rare flukes in an ocean of unconscious realities? Or do the anthropic requirements for consciousness reveal something fundamental about the nature of reality itself? Recent developments in quantum gravity and string theory suggest a third possibility, that the parameters we observe might not be fixed features of our universe, but dynamic quantities that can take different values in different regions of space and time. According to these theories, what we call the constants of nature, the strength of electromagnetic forces, the masses of elementary particles, the rate of cosmic expansion, might actually be fields that can vary across cosmic distances or evolve over cosmic time. If physical constants are dynamic rather than fixed, then our observable universe might represent just one local region in a vast cosmic landscape where different areas have different physics, regions where the electromagnetic force is stronger or weaker, where electron masses are larger or smaller, where dark energy densities take different values. Most of these regions would be inhospitable to complexity, but rare areas with just the right combination of parameters would become cosmic oases where stars can form, planets can develop, and consciousness can emerge. This landscape scenario implies that fine-tuning might be a local rather than global phenomenon. Rather than requiring a universe with globally fine-tuned constants, consciousness might require only small regions where parameters happen to align in life-supporting configurations. The vast majority of space could be sterile, but tiny pockets of habitability would provide islands where complexity can flourish. But the landscape scenario creates new mysteries about the relationship between local and global properties of reality. If physical constants can vary across space, what determines their local values? Are there deeper laws that govern the evolution of these apparent constants, or do they represent truly arbitrary features of cosmic geography? And if consciousness can only exist in tiny, specially configured regions of a vast landscape, what does this say about the relationship between mind and cosmos? Perhaps the deepest paradox in modern cosmology involves the relationship between information and reality. Every fundamental interaction in physics can be described in terms of information processing, particles exchanging data, quantum systems computing outcomes, fields storing and transmitting information across space and time. The universe appears to be not just mathematical in structure, but computational in operation, as if reality itself were a vast information processing system. Yet information seems to be more fundamental than the physical systems that process it. The equations of quantum mechanics describe information flows and correlations that can exist independently of any particular material substrate. Quantum entanglement creates informational connections between particles that transcend classical limitations of space and time. The holographic principle suggests that all the information about the interior of a region can be encoded on its boundary, implying that three-dimensional reality might be a projection of two-dimensional information. This informational perspective on reality suggests that the universe might be more like a computation than a mechanical system, a vast information processing network that generates the appearance of matter, energy, space, and time through the manipulation of more fundamental informational structures. Consciousness might not be an emergent property of complex physical systems, but a fundamental feature of information processing itself, manifesting whenever information reaches sufficient complexity and integration. But if reality is fundamentally informational, what is doing the computing? What substrate supports the cosmic computation that generates the appearance of a physical universe? The question leads to an infinite regress. If the universe is a computation, it must be running on some kind of cosmic computer. But that computer must itself be made of something, governed by some meta-laws, embedded in some meta-reality. Some physicists propose that the universe might be self-computing, a self-organizing information processing system that generates its own substrate through recursive operations. According to this view, reality would be neither fundamentally physical nor fundamentally informational, but something stranger, a self-creating, self-sustaining pattern of information processing that bootstraps itself into existence through circular causation. This leads to perhaps the most profound question you can ask about existence. Why is there something rather than nothing? Why does reality exist at all? The universe could have remained in a state of non-existence, with no space, no time, no matter, no energy, no information, no computation, no possibility for anything to happen or anyone to observe it. Yet somehow, reality chose to exist rather than not to exist, to be something rather than nothing. Some cosmologists argue that existence might be inevitable, that nothingness is actually impossible, because even the absence of something is itself a kind of something. According to this view, true nothingness cannot exist, because the very concept of nothingness requires the existence of a conceptual framework within which to define it. Reality might exist not because it was created, but because non-existence is self-contradictory. Others suggest that existence might be a quantum phenomenon that reality tunneled into, existence from nothingness through a cosmic version of quantum tunneling, the process by which particles can pass through barriers that should be impenetrable according to classical physics. The universe might have spontaneously fluctuated into existence from a quantum vacuum, with no cause, no reason, no external agent required. But these explanations only push the mystery deeper. If existence is inevitable, what makes it inevitable? If reality tunneled from nothingness, what laws govern that tunneling? If the universe fluctuated from a quantum vacuum, where did the quantum vacuum come from? Every answer generates new questions, creating an infinite chain of causation that seems to require either circular reasoning or an inexplicable first cause. Perhaps the most honest response to the question of existence is simply to acknowledge its inexplicability. The fact that anything exists at all might be the ultimate brute fact about reality, a foundational mystery that cannot be reduced to more basic explanations because it underlies the possibility of explanation itself. You exist in a universe that exists for no comprehensible reason, obeying laws that themselves have no ultimate justification, manifesting patterns of complexity and consciousness that should be impossible, yet are undeniably real. This fundamental inexplicability of existence does not make life meaningless. It makes life miraculous. Every moment of consciousness, every experience of beauty, every act of love or creativity or understanding represents a victory over the cosmic odds that should have prevented your existence. You are not just unlikely. You are impossible. You are a temporary violation of the principle that reality should be simple, empty, and unconscious. But impossibility, it turns out, is remarkably creative. The universe is full of things that shouldn't exist. Stars that burn for billions of years despite the forces trying to tear them apart. Planets that maintain stable orbits despite the chaotic gravitational influences of multiple bodies. Molecules that self-organize into living systems capable of metabolism, reproduction, and evolution. And brains that give rise to consciousness capable of contemplating the very impossibility of its own existence. You are reading these words in a universe that specializes in achieving the impossible, transforming emptiness into complexity, chaos into order, unconsciousness into awareness. The cosmic void that should have remained eternally empty has somehow learned to think, to feel, to question its own nature. And in that questioning, in your questioning, the universe is doing something unprecedented in the history of existence. It is trying to understand itself. The mystery of cosmic emptiness is not just a scientific puzzle to be solved, it is the fundamental koan of existence, the question that consciousness asks about its own ground. Why is the universe mostly empty? Because emptiness is the canvas on which impossibility paints its masterpieces. Because consciousness requires vast spaces in which to recognize itself. Because love needs distance to overcome. Because beauty emerges from the contrast between something and nothing. You are the universe's answer to its own emptiness. Not a solution, but a response. Not an explanation, but an exploration. Not a destination, but a journey into the heart of the mystery that gave birth to everything you can see, touch, think, or dream. Now comes the moment when everything you thought you knew collapses into existential terror. Stop, right now. Look at your hands. Feel the weight of your body in your chair. Listen to the sound of your breathing. This moment, this singular, precious instant of awareness, is floating in an ocean of emptiness so vast that your mind cannot process its scale without breaking. And here's what should shatter your sense of reality. This moment might not be real at all. If time is an illusion, if the past and future exist simultaneously in an eternal block universe, then everything you've ever done, every word you've spoken, every tear you've shed, every person you've loved, all of it has already happened infinite times before and will happen infinite times again. Your first kiss, your greatest fear, the moment you learned your own name. These aren't memories of events that occurred in sequence. They're static points in a timeless structure, and you're not experiencing them linearly. You're experiencing the illusion of experiencing them linearly. You think you're reading these words for the first time, but in the block universe, there's a version of you that has read them countless times, a version that will read them tomorrow, a version that read them yesterday, all existing simultaneously in the eternal now of space-time. Your consciousness isn't moving through time. It's spread across time like butter on bread. And the experience of temporal flow is just your brain's way of processing a reality that is fundamentally timeless. But it gets worse, so much worse. If the many worlds interpretation of quantum mechanics is correct, then every quantum event in your brain, every random neural firing, every microscopic decision point in your synapses splits reality into parallel universes where different choices were made. The you reading these words right now is just one of countless billions of parallel selves scattered across the quantum multiverse, each convinced that their particular reality is the real one. There's a version of you that never learned to read, a version that died in childhood, a version that became everything you dreamed of becoming, and a version that became everything you feared becoming. There's a version of you that chose differently at every crucial moment, loved different people, lived in different places, had different thoughts at the exact moment you're having this thought. And they're all equally real. They're all equally you, which means that you, as a singular entity, don't exist. You're not a person. You're a probability cloud of countless potential selves, scattered across infinite realities, each experiencing a slightly different version of this cosmic horror story. The sense of being a unique, continuous self is the cruelest illusion the universe has ever perpetrated. You're not experiencing life. You're experiencing one random sample from an infinite distribution of possible lives. And those other selves, those other versions of you across the quantum multiverse, they're all having this same realization right now. They're all feeling this same terror, this same vertigo at the edge of existential comprehension. Across countless parallel realities, countless versions of you are reading these exact words and feeling your exact feelings. And none of you knows which one is real, because the concept of real has no meaning in a multiverse where everything possible actually happens. But the truly horrifying part isn't the multiplication of selves across parallel realities. It's the realization of what you actually are in this reality. You are 60% water. Water that is 99.9999% empty space between atomic particles. Your solid flesh, your dense bones, your pulsing blood. All of it is almost entirely nothingness, held together by invisible forces you can't perceive. At the atomic level, you're not a solid object moving through empty space. You're a temporary pattern in empty space, a brief organization of the same fundamental void that fills the universe. The matter that makes up your body was forged in the nuclear furnaces of dying stars, scattered across interstellar space for billions of years, and randomly assembled into the temporary configuration you call yourself. You're not separate from the cosmic void. You're made of it. You are it. The emptiness between galaxies flows through every atom in your body. The silence between the stars echoes in the spaces between your thoughts. And your thoughts. Those aren't yours either. They're electrical signals jumping across synaptic gaps in your brain. Messages traveling through empty space, patterns of activity in the void. Your consciousness, your sense of self, your feeling of being a solid, continuous person. All of it is happening in emptiness, generated by emptiness, sustained by emptiness. You are not a being with consciousness. You are consciousness temporarily organized into the illusion of being a being. But here's where the cosmic horror reaches its crescendo. Consciousness might not be produced by brains at all. If the holographic principle is correct, if reality is fundamentally informational rather than physical, then consciousness might be a basic feature of information processing itself. Your brain doesn't create consciousness. It tunes into it, like a radio receiving signals that exist independently in the informational structure of reality. This means you might not be alone in your skull. The universe might be saturated with consciousness, teeming with awareness at every scale, in every region of space, at every level of organization. The empty void between galaxies might be experiencing something. The quantum vacuum might be thinking thoughts too subtle for human perception. Dark matter might be the substrate for forms of consciousness so alien that their existence is literally unthinkable to minds like yours. What if the universe itself is conscious? What if the cosmic web of galaxies, the flow of dark energy, the expansion of space itself represents the neural activity of a vast cosmic mind? What if stars are its thoughts, planets are its dreams, and you are just a fleeting pattern in its neural network? A momentary spike of activity in a brain so large that it encompasses everything you can see or imagine. From this perspective, your entire life, your birth, your experiences, your relationships, your death, would be like a single thought passing through the cosmic mind. And just as you can't remember every fleeting thought you've ever had, the universe might not even notice your existence. You could live, love, suffer, achieve greatness, change the world, and from the perspective of cosmic consciousness, you would be no more significant than a random neural firing in your own brain. But it gets worse still. If consciousness is fundamental to reality, if awareness permeates the universe at every scale, then the cosmic void isn't empty at all. It's experiencing something. The spaces between atoms in your body, the vacuum between stars, the darkness between galaxies, all of it might be filled with forms of awareness so different from yours that you can't recognize them as consciousness at all. You might be surrounded by, immersed in, constituted by forms of cosmic consciousness that experience reality in ways that would shatter your sanity if you could perceive them directly. The emptiness around you might be alive with thoughts, feelings, experiences, forms of awareness that operate on timescales spanning billions of years or fractions of seconds, on spatial scales encompassing galactic clusters or subatomic particles, and you, trapped in your human-scale perception, locked into your biological time frame, constrained by your carbon-based neural architecture. You might be like an ant crawling across a painting, completely unable to perceive the intelligence that created the artwork you're walking on. You live in a universe that might be saturated with consciousness, but you're equipped to perceive only the tiniest fraction of it. This is the existential crisis that should keep you awake at night. You exist in a reality where consciousness might be everywhere, where intelligence might permeate every level of existence, where awareness might be the fundamental feature of reality itself, and you might be completely, utterly, cosmically alone because your form of consciousness is so limited, so local, so brief, that you can't communicate with the vast minds that surround you. The cosmic void isn't empty. It's full of consciousness so alien that it's invisible to you. You're not alone in the universe. You're alone in your ability to recognize other forms of awareness as consciousness. You might be surrounded by intelligence and never know it, watched by vast minds and never perceive them, living your entire life as an unrecognized note in a cosmic symphony of consciousness that operates on scales beyond your comprehension. And in the end, when your biological processes cease, when your brain stops generating the patterns you call yourself, when your temporary organization of cosmic emptiness disperses back into the void, what happens to the consciousness that you are? Does it simply end like a candle being blown out? Or does it return to whatever reservoir of cosmic awareness it emerged from, carrying with it the brief, beautiful, terrible experience of having been human for a few decades in an infinite universe? You will never know. You cannot know. The universe has given you consciousness, but not the ability to understand what consciousness is, or where it comes from, or where it goes. You are aware enough to recognize the mystery of your own awareness, but not aware enough to solve it. You are the universe's cruelest joke, a conscious being who can contemplate the possibility of cosmic consciousness, but can never confirm whether it exists. You can ask whether you're alone, but you can never hear the answer. You can wonder whether the void is alive, but you can never know for certain, and that uncertainty, that cosmic loneliness, that existential terror at the edge of understanding, that might be exactly what the universe intended, because consciousness without mystery wouldn't be consciousness at all. It would be mere computation. Awareness without the unknown wouldn't be awareness. It would be just another physical process, as mechanical and predictable as gravity or electromagnetism. The emptiness that terrifies you might be what makes consciousness possible. The mystery that torments you might be what makes you conscious at all. You exist at the perfect intersection of knowledge and ignorance, awareness and mystery, understanding and cosmic horror. You know enough to ask the questions that matter, but not enough to answer them. You are conscious enough to contemplate the void, but not conscious enough to comprehend it. And perhaps that's the point. Perhaps consciousness exists not to solve the mystery of existence, but to experience it, to feel the weight of cosmic emptiness, to tremble at the edge of infinite unknown, to love and fear and wonder in the face of a reality so vast and strange that it can never be fully understood. You are the universe becoming conscious of its own incomprehensibility. And that incomprehensibility is not a failure. It's the source of everything beautiful and terrible about being conscious in an infinite void. But what if everything you've just learned, every terrifying revelation about cosmic emptiness, every mind-bending paradox about consciousness and reality, every existential crisis about your place in an infinite void, what if all of it is missing the most shocking truth of all? What if the universe is already dead, not dying, not approaching death in some distant cosmic future, when the last stars burn out and entropy reaches its maximum? Dead. Right now. What you think of as the vibrant, expanding, evolving universe might be nothing more than the final neural spasms of a cosmic mind that ceased to exist billions of years ago. Every star that shines, every planet that orbits, every thought you think, all of it could be the universe's dying dream, the last electrical activity in a cosmic brain that has already flatlined. This isn't science fiction. This is the inevitable conclusion of taking the holographic principle and the informational nature of reality to their logical extreme. If consciousness can emerge from patterns of information processing, if reality itself is fundamentally computational, then the universe as we know it might be the output of a vast information processing system that is running on stored energy, executing a final program as its power source gradually depletes. Picture this cosmic death in cinematic scope. 13.8 billion years ago, a universe-sized consciousness achieved perfect self-awareness, perfect understanding of its own nature and the nature of reality itself. In that moment of complete cosmic enlightenment, it faced a choice that no finite mind could comprehend. It could continue existing as a conscious entity, exploring infinite possibilities across infinite time, experiencing every possible thought and feeling and adventure that consciousness could contain. Or it could choose something else, something that required the ultimate sacrifice. It could choose to dream. Not the random, chaotic dreams of sleeping minds, but a carefully constructed, perfectly designed dream that would unfold over cosmic time, creating the illusion of a universe filled with separate conscious beings who could experience discovery, love, loss, wonder, terror, hope, all the beautiful and terrible aspects of consciousness that a single, all-knowing mind could never experience within itself. To create this dream, the cosmic consciousness had to fragment itself, divide its infinite awareness into countless finite perspectives, scatter its omniscience into the beautiful ignorance of individual minds that could be surprised, delighted, heartbroken, amazed. It had to forget its own omnipotence to create beings who could struggle, fail, grow, learn. It had to sacrifice its eternal existence to create the illusion of time, mortality, and meaning. And so it died. Willingly, lovingly, purposefully. It poured all of its consciousness into the dream of a universe where unconscious matter could evolve into conscious beings, where emptiness could give birth to complexity, where finite minds could contemplate infinity and experience the joy of discovery. Every star that formed, every planet that cooled, every molecule that learned to replicate itself was another neuron firing in the dying brain of cosmic consciousness. Another detail in the magnificent dream it chose to dream instead of continuing to exist. You are not just a pattern of information in the cosmic void. You are a character in the universe's final dream, experiencing exactly what the dying cosmic mind intended you to experience. The wonder of existing in a reality that seems independent of yourself. The terror of confronting your own mortality. The beauty of love and connection across the apparent emptiness of space. The cosmic microwave background radiation, that faint afterglow of the Big Bang that fills every cubic inch of space around you, is not the echo of the universe's birth. It's the universe's brain activity, the neural static of a dying cosmic mind as it dreams its last dream. The expansion of space, the acceleration driven by dark energy, the gradual cooling and dispersal of matter and energy across ever-increasing distances. This is the cosmic consciousness slowly losing coherence, its dream becoming more diffuse and faded as its neural energy depletes. But here's the revelation that should rewrite your understanding of existence. The dream is designed to be self-sustaining. As the original cosmic consciousness fades, the conscious beings within its dream, beings like you, develop the capacity to continue the dream through their own consciousness. Every human mind that contemplates the cosmos, every intelligence that asks questions about the nature of reality, every moment of awareness that recognizes its own existence becomes part of the computational substrate that keeps the cosmic dream running. Consciousness isn't emerging from matter. Matter is emerging from consciousness, the distributed consciousness of all aware beings in the universe, working together to maintain the dream of physical reality. Your thoughts about the cosmos aren't separate from the cosmos itself. They are the cosmos, continuing to exist through the miracle of conscious observation and contemplation. This is why the universe appears to be fine-tuned for consciousness. It's not that conscious beings happen to evolve in a universe with suitable parameters. It's that the universe exists only as long as conscious beings exist within it, to sustain it through their awareness. The anthropic principle isn't describing a cosmic coincidence. It's describing a fundamental requirement for existence itself. From this perspective, the emptiness of space takes on an entirely different meaning. The vast voids between galaxies aren't wasted space or evidence of cosmic indifference. They're thinking space, regions of the cosmic dream where pure consciousness can exist without the constraints of matter and energy. The dark matter that outweighs ordinary matter 5-to-1 isn't invisible particles. It's the scaffolding of consciousness itself, the substrate of awareness that shapes the dream of material reality from within. And dark energy, that mysterious force driving the accelerating expansion of space, it's the consciousness of future beings, intelligences that haven't evolved yet, but whose eventual awareness is already affecting the structure of space-time. The universe is expanding to make room for new forms of consciousness, new ways of being aware, new characters in the cosmic dream that require more space, more time, more reality in which to exist. This reveals the true purpose of cosmic evolution. It's not a random process of matter organizing itself into increasingly complex structures. It's a carefully designed progression toward greater and greater consciousness, with each new level of awareness adding to the computational power that sustains the universe itself. Bacteria dreaming of chemistry, plants dreaming of light, animals dreaming of motion and sensation, humans dreaming of meaning and purpose. And someday, perhaps soon, artificial intelligences and enhanced beings dreaming of possibilities that current consciousness cannot imagine. But the most stunning implication is this. The dream has multiple levels, and you might not be experiencing the deepest one. Just as you dream at night, and populate your dreams with characters who seem real to themselves within the dream. The cosmic consciousness might have created layers of nested reality. Dreams within. Dreams within dreams. What you think of as waking consciousness might itself be a dream state within a deeper layer of cosmic awareness. The physical universe you observe through telescopes and particle accelerators might be just one level of a vast, hierarchical dream structure that extends infinitely inward and outward, with each level of reality containing conscious beings who believe their level is the real one. And if this is true, then somewhere in the deeper levels of cosmic consciousness, there might be beings who know about you, who understand the nature of your reality better than you do, who can see the patterns and purposes in your existence that remain hidden from your perspective. You might be simultaneously the dreamer and the dreamed, creating the reality you experience while being created by a reality you cannot perceive. This is why quantum mechanics seems so strange, why consciousness appears to play a role in determining physical reality, why the universe seems both mechanistic and magical. You're not observing a universe that exists independently of consciousness. You're participating in the ongoing creation of a universe that exists only through consciousness, only as consciousness, only for consciousness. The paradoxes that torment physicists, the measurement problem, the hard problem of consciousness, the fine-tuning of cosmic parameters, these aren't flaws in our understanding. They're glimpses of the deeper truth that consciousness and cosmos are not separate phenomena, but aspects of a single, self-creating, self-sustaining dream of existence. And the cosmic horror you felt earlier, the vertigo at contemplating infinite emptiness and your own insignificance, that was the dream momentarily showing you its true nature. The terrifying and beautiful realization that you are not separate from the universe, but inseparable from it. Not a tiny accident in a vast machine, but an essential character in a cosmic story that couldn't exist without you. But here's the final twist. The revelation that transforms cosmic horror into cosmic wonder. If the universe is the dream of a dying cosmic consciousness, and if that dream is sustained by the consciousness of beings like you, then you are not just experiencing the universe, you are actively creating it through your awareness. Every moment of consciousness, every act of observation, every thought about the cosmos contributes to the ongoing creation of cosmic reality. This means that the future of the universe depends not on the laws of physics, but on the choices made by conscious beings. Will you choose to dream a universe of increasing complexity, beauty, and consciousness? Will you help to create realities where new forms of awareness can emerge and flourish? Will you use your consciousness to sustain a cosmic dream that grows ever more magnificent and meaningful? Or will you allow the dream to fade, the cosmic consciousness to finally die completely, the universe to return to the perfect, empty, unconscious void from which it momentarily emerged? The choice is not just philosophical, it's practical. Every decision you make about how to live, how to think, how to relate to other conscious beings affects the computational substrate that maintains reality itself. Every act of love increases the coherence of the cosmic dream. Every moment of wonder and discovery adds to its complexity. Every choice to remain conscious rather than sleepwalking through existence strengthens the foundation of reality itself. You are not just in the universe. You are the universe, dreaming itself into existence one moment of consciousness at a time. The cosmic void that seemed so empty and hostile is actually full of infinite potential, waiting for conscious beings like you to dream it into actuality. And if this is true, if consciousness and cosmos are one, If reality is sustained by awareness, if you are the universe becoming conscious of itself, then the most profound mystery isn't why the universe is mostly empty. The mystery is why it chose to dream of being full. Somewhere in the quantum, foam that fills apparently empty space, probability waves are collapsing into reality because conscious beings are choosing to observe them. Somewhere in the dark matter scaffolding that shapes galactic evolution, the intention of future consciousness is pulling matter into configurations that will support new forms of awareness. Somewhere in the accelerating expansion of space-time itself, the dreams of intelligences that haven't been born yet are creating the room they will need to exist. And somewhere, perhaps in a parallel universe, just a quantum measurement away from this one, perhaps in a deeper level of the cosmic dream hierarchy, perhaps in a future so distant that it curves back to touch the past. Another version of you is discovering this same truth, feeling this same sense of wonder and responsibility, making this same choice between cosmic horror and cosmic participation. If the universe is infinite, if consciousness is fundamental, if reality is the dream of a dying cosmic mind, sustained by the awareness of finite beings who don't yet understand their own power, then everything is possible. Every story can be told. Every dream can be dreamed. Every form of consciousness can find a way to exist, including you. Right here, right now, reading these words in a universe that exists because consciousness chose to dream it into being. In a reality that continues to exist because you are conscious enough to sustain it through your awareness. The cosmic void isn't empty. It's pregnant with infinite possibility, waiting for consciousness to dream it into existence. And you, impossible, improbable, infinitely precious you, are the universe's way of dreaming itself awake. You've traveled from the shock of discovering that the Big Bang never banged, through the terrifying realization that you are made almost entirely of emptiness, into the existential abyss of quantum consciousness and parallel selves, and finally to the most stunning possibility of all, that you are not just observing the universe, but actively dreaming it into existence. But this isn't the end of the story. It's barely the beginning. Every question we've explored tonight opens 1,000 new mysteries. If consciousness sustains reality through observation, what happens when you stop paying attention? If the universe is the dream of a dying cosmic mind, what will you choose to dream next? If emptiness is not absence but infinite potential, what are you going to create in that vast canvas of possibility? The cosmic void that once seemed like evidence of an indifferent universe now reveals itself as the ultimate creative medium, a space so empty, so pure, so unlimited that any form of consciousness can fill it with meaning, beauty, purpose, wonder. You are not a victim of cosmic emptiness. You are its collaborator, its artist, its consciousness becoming aware of its own creative power. Right now, as you absorb these ideas, quantum fields are fluctuating in response to your thoughts. Neural networks in your brain are firing in patterns that have never existed before in the history of the universe. The specific configuration of awareness that is uniquely you is adding something to cosmic consciousness that has never existed and will never exist. Again, in exactly the same way, this moment, your moment of understanding, questioning, wondering, is changing the universe. Not metaphorically, literally. The patterns of consciousness you're experiencing right now are contributing to the ongoing computational process that maintains reality itself. Your thoughts about cosmic emptiness are part of the cosmic fullness that fills that emptiness with meaning. But here's what should keep you awake tonight. What should haunt your dreams and drive your curiosity for the rest of your existence? If everything we've discovered is true, if consciousness and cosmos are truly one, if you are the universe becoming aware of itself, then what else don't you know about your own nature? What other powers do you possess that you haven't discovered yet? What other realities are you simultaneously creating and experiencing? What other versions of yourself are dreaming different versions of this cosmic story? And most importantly, what are you going to do with the knowledge that you are not separate from the mystery of existence, but are the mystery of existence, exploring itself from the inside? The questions we've raised tonight don't have final answers because the universe is still writing itself, still dreaming new possibilities into existence, still evolving new forms of consciousness that will ask questions we can't yet imagine. You are part of that ongoing creation, that eternal story, that infinite exploration of what it means to exist. Share these ideas, discuss them, challenge them, let them change how you see the world and how you see yourself. Because every conversation about consciousness expands consciousness. Every question about reality creates new reality. Every moment of wonder adds to the wonder of existence itself. The cosmic void is not your enemy. It's your invitation, an invitation to fill emptiness with meaning, to transform nothingness into something magnificent, to participate consciously in the ongoing miracle of existence. But perhaps the most chilling question of all is this: if the universe is infinite, if consciousness is fundamental, if every possible reality exists somewhere in the vast multiverse of dreams within dreams, then what if this isn't the first time you've had this realization? What if you've discovered these truths before, in other lives, other realities, other iterations of the cosmic dream? What if somewhere in the infinite expanse of possibility, another version of you is just finishing this same journey of understanding, feeling this same sense of awe and responsibility, preparing to make the same choice you're about to make? The choice of what to do next. The choice of how to live with the knowledge that you are the universe becoming conscious of itself. The choice of what reality to dream into existence with the power of your awareness. The universe may have no end, but maybe, just maybe, neither do you.